Alright, so Chris, this is your first class. So you will have a lot of questions about what we do in the class, how we learn, how do we kind of try decoding the concepts that we are supposed to learn as part of pre-calculus. So please feel free to reach out to me outside the class also. Since you have my WhatsApp number, you are part of WhatsApp group, you know my number. So if there is any any question, anything that you are struggling with, that something that you want to clarify, you can always send me a WhatsApp message, and then we can work through that outside the class also. And that is not only an offer for Chris, that is an offer for Prisha, that is an offer for Dhanushri and every student of mine. Okay?
Yeah, thank you.
Alright. Now, I'm assuming that whatever we have learned before, except Chris, I mean Chris, this is your first class, but whatever we have learned before, that part is understood and there is no doubt. Is that a fair statement, Prisha and Dhanushri? Based on your previous classes, whatever we have learned?
Yes, sir.
Oh, okay. Alright. Now today, so again, just to confirm everybody, if you look at pre-calculus as a syllabus, I follow Khan Academy. So Khan Academy, if you go to, you will find that there are total 12 or 13 units for pre-calculus. Right now, so far we have finished 3 units, which is up till complex number, and we are starting the 4th unit today, which is nothing but rational fractions. Rational expressions, not fractions. Rational expressions and related concepts. So every unit that we pick up, it takes us 2 to 3 classes to finish that unit. Okay, so we'll start with rational expression today, and I had mentioned what are the things that we are going to cover. So let me quickly do a recap of what all we are going to learn today in the class, and at least we'll try to, and we'll see what spills over to the next class. So the things that we're going to cover are reducing rational expression to lowest term, understanding what is domain of expression, then we'll talk about end behavior of rational functions, and then discontinuities of rational functions, removable, discontinuous, zero and vertical asymptotes. So that is at a high level what we are going to cover. So before I get started, can somebody tell me, when you hear the term rational expression, what exactly comes to your mind? As a starting point. No gimmicky stuff. In plain simple terms, when you hear the term rational expression, what does come to your mind? Any thoughts? Chris, Dhanushri, Prisha, and my request to you guys would be keep it as interactive as possible. I mean, if you don't know, you don't know. That's okay. That's why we are here. If there's something to be learned, you can just acknowledge that yes, I have not come across this, or I have not dealt with this. No response? Okay. So let's first break it down. We are talking about rational and expression. Yep. These are the 2 words that it is made of. When you talk about rational, immediately the thing that comes to your mind is something which is in the form of fraction. Yeah, makes sense? And then when you say expression, I'm not essentially talking about my expression, I'm talking about something which is not an equation but has variables and constants. There is no output, there is no equal to sign. So it's an expression without any output. Meaning something which has variables and constants into it, but there is no equal to sign. There is no output coming out of it. Is that a good starting point? Rational and expression. Yeah? Yeah. And Prisha and Dhanushri, you guys have to also keep on reacting, keep on responding to my my queries, so that way at least I get the confidence that yes, I'm teaching and I'm reaching as well. Yeah? Okay. Now, since we have done the breakdown of what this means in terms of English. Now let's look at it. So basically, now we know what is expression. We know, let's say 8. This is an expression, but this is still not a rational expression because it's not in the form of a fraction. As soon as I add something like this, now you can see this is an expression, this is also an expression, and this is the rational form. That is what is rational expression at a concept level. So next time when you guys hear the term rational expression, this is what should pop in your mind, that okay, we are talking about expression which is in the fraction form. Is that making sense so far?
Yep.
Okay. Now let's go further into it. Now the first thing that you want to understand is, I mean, your rational expression could be in any form. Let's say x to the power 7 minus x to the power 6 plus 5x cube plus 2x minus 9. And then as a denominator, let's say you have x squared minus, let's say 4x cube minus x squared plus 7. Is this something that we like when we see it? It doesn't sound very, easy to deal with. If I have something like x plus 4 by x minus 3, this is interesting. This makes life, this makes us deal with something simpler in nature compared to what we are seeing above. Agree? So essentially the first thing that we do or that we want to do when we deal with rational expression is simplify it in the lowest term. When you say lowest term, meaning something which is much simpler in nature, something which has lesser value when it comes to the exponent. So if you have to compare between, let's say, x squared minus 4x plus 4 by x plus 2, between this one and x minus 2 by, let's say, x plus 1, you would certainly be more inclined towards looking at this guy compared to this guy. So your end goal is to find out ways to simplify a rational expression to a lower term or to a lower value of the exponent in the numerator and denominator. Make sense? So that will be our starting point. Whenever we deal with a rational expression, our first goal is to simplify that to the lowest form, and then we can, then we would be able to deal with things in a better, easier way. So now let's look at what are those tips and tricks that helps us simplify a rational expression. Let's say if I have x squared minus 6x plus 9 divided by x plus 3, let's say x squared minus 9. If I have, this is a legitimate rational expression, correct? I mean, I have expression in the numerator and I have expression in the denominator also. Now, when we have to deal with this, what we want to do or what we get tempted to do is, can I factorize this? If I have, let's say, I mean, before we go to rational expression, let's say if I have 8 by 24, we don't feel comfortable with this. What we do is, let's say 8 I can write as 8 into 1 and 24 I can write as 8 into 3, and then these common factors I can knock off. So that way I am dealing with a much simpler fraction form, or the fraction the simplest form. So is the objective in case of this also. So essentially what we are trying to do is, we are trying to figure out ways to find out, factorize the numerator and denominator and see what are those common factors that we want to kind of try knocking off. So that way this becomes simplified, right? Just to give an example, if you look at this, it's a squared minus 2ab plus b squared, where a is x and b is 3. So this is a squared, this is a squared plus 2ab, a is x squared plus 2ab, 2 times 3 times b, 2 times x times 3, So a square minus 2ab plus b square. So this is nothing but x minus 3 whole square divided by x square minus 9, which is again a square minus b square, which will be a plus b into a minus b. Is it going well with everybody? Are you guys able to make out what I'm trying to do with this and this? Yeah? So this is my a square minus b square, which is a plus b times a minus b. This is my a minus b whole square, where a is x and b is 3. So when you look at this, then that rings the bell for us. So this is like x minus 3 into x minus 3 divided by x plus 3 into x minus 3. Now see how it is kind of getting simpler, more amicable for that matter, right? This x minus 3 and this x minus 3 I can knock off. Then I'm left with x minus 3 by x plus 3. This is the objective that we are working towards when it comes to simplifying a rational expression to the lowest term. Are you guys with me so far? Dhanusri, I am just wanting to confirm that you are with me as well. Yeah?
Yes, sir.
Oh, okay. No, so again, I'm just making sure that every child in the class is with me. If there's any doubt, just feel free to ask. Okay. So now, this is our first objective. If I have any rational expression, the first thing that we are wanting to achieve is simplify that into the lowest, into a form with the lowest term. So we saw this happening here, and this rational expression translated into x minus 3 by x plus 3, which is what we are wanting to achieve. I mean, in general. I mean, this is just an example, and we can have hundreds and thousands of examples, like this. But so far, this is okay. Now, there's one thing that you would want. See, when you are trying to resolve a rational expression, what is ultimately we are trying to do? Our unknown is x. We are trying to find out when we try resolving this expression, what are the potential value of x that we are looking at? What are the possible values of x that would satisfy this condition? So each and every value of x that satisfies this condition, or that is a legitimate solution that could potentially, that we can potentially arrive at, that is what we are trying to achieve, right? If you have an expression, if you have an equation, eventually you are dealing with variables, and your goal is to figure out the possible values of the variable. Agreed?
Yeah.
Now, from this expression also, if we can determine what are the possible values of x, which gives me a valid, or which can potentially give me valid answers for this, that would be called the domain of the expression. Meaning, let's say, if I say x equal to 4, will that give me a legitimate answer? So x equal to 4, this will become 16 minus 6 times 4, 24. 16 minus 24 is minus 10 plus 9 minus 1 divided by 4 square. 16 minus 9 is 7. So minus 1 by 7. That sounds like a valid answer. Let's put that value. Let's say, if I say, will x equal to 1 give me a valid answer? Let's put that value. So it's 1 square minus 6 into 1 plus 9 by 1 square minus 9. So this is 1 minus 6 is minus 5 plus 9 is plus 4 divided by 1 minus 9 minus 8 minus 1 by 2. Still a valid answer. This is still a defined answer. The problem happens when you try dividing something by a 0, right? That becomes infinity. All those scenarios are considered not a valid value for x, or not in the domain of this expression. So every value of x that gives you a legitimate or valid or what you call an acceptable solution, that is what is called the domain. So basically, if I put 1, I get minus 1 by 2. So that's in the domain of this expression. Similarly, if I put x equal to 4, then I can put that value, it becomes 4 square minus 6 into 4 plus 9 by 4 square minus 9. So that is 16 minus 24 is minus 8 plus 9 is 1 by 16 minus 9 is 7. This is still a legitimate answer. So this is, we can say 4 and 1 are in the domain. And likewise, there could be multiple possible values of x which will give you a legitimate answer or a valid answer. Those are called the domain of the expression. Are we okay with that understanding? Yeah. Now, interestingly, when we were trying to solve this expression and we came to this point and we knocked off x minus 3 and x minus 3 because these were common. If you look at this carefully, what is happening here is, if you put the value of x equal to 0, x equal to 3 in this expression, so this will become 0. So you are dividing something by 0. Dividing something by 0, what does it mean? This is an undefined state of an answer. I mean, we say this is infinity, but there's nothing called infinity that at least you and I can deal with, right? I mean, if I say I'll give you infinity dollars, I'm not even clear about how much I'm wanting to give. I'm just saying that I'll give you a huge number of dollars. That could be billions, gajillions, trillions, or Google numbers, right? Hey Dev.
Hi, sir.
Love. So yeah. So Dev, we have started unit 4, which is called the rational expression, and we just started with the first part where we are talking about what do we mean by simplifying a rational expression to the lowest term. Meaning, we have an expression in the numerator and an expression in the denominator. How do we solve it to get to the simplest possible form? Yeah. So, whatever part you have missed, Dave, that you'll be able to catch up because I'll keep coming back to this one. So that way you would not be missing anything. Yes, Prisha.
Sir, I was wondering if rational expressions can have no real number solutions.
So basically, when you say non-real numbers, meaning undefined solutions, is that what you're talking about?
Yeah, kind of.
Yeah. So there are two ways of looking at it. One is an unreal value for your variable, and we'll come to that. Okay. When I say x is infinity or negative infinity or tending towards negative or positive infinity, that is one scenario. And second scenario is when you put some value of x and then the whole expression itself gives you a non-real answer or unrealistic answer or unacceptable or illegitimate answer kind of a thing, right? So we'll look at all those possible scenarios. Yeah.
Okay, thank you.
All right. So far, let's look at one more scenario, okay? And then probably that will clear a little more dust from what we are trying to learn as part of this. So our first objective. So they just pay attention. This might be a fresh start. Let's say when I say rational expression, I'm talking about something like this. I'm talking about something like this, let's say, divided by this. Now, so I have an expression in the numerator and I have an expression in the denominator. What is that we are trying to achieve here is, we are trying to see how we can simplify this further. Let's say if this becomes x plus 1 by 2. This is our desired state. We are trying to simplify this and get to something simpler than what we see above. So that is called simplifying a rational expression to the lowest term. Yeah. And I always claim that whatever we try learning in a math class, our goal is to simplify things, make things more amicable, much more easier to digest or interpret. So that is our goal here. Now, here when you look at this expression, what I was saying was, a domain of an expression means all the possible values of, or all the real values of x, which will give me a real outcome for this whole expression. Okay, so let's say in this expression, if I put x equal to 6, what happens? It becomes 6 square minus 6 into 6 minus 5 divided by 6 minus 5. 36 minus 36 is 0, minus 5, so this becomes minus 5 by 1. Still acceptable, valid number that we're dealing with. So this is this. So you will say that x equal to 6 is in the domain of the expression. Likewise, you can find out different values of x, for which you will get a real value of the overall expression, and those values of x are called the domain of the expression. Is that part okay with everybody?
Yeah.
Yeah. Now, but this is like a wild goose chase. We are randomly picking up all possible numbers. I'll put 6, next I'll put 7, then I'll put 24, then I'll put 105, and keep on doing that. Not fun. This is not the way we want to do it. So, what we do is, we simplify this expression first. And from this one you can see, this is x square minus 6s minus 5. So, I can break this into x square minus 5x plus x, minus x, and this is actually plus 5, okay? Plus 5, I can break it down like this. And this is again, this goes by how we have learned how to solve a quadratic equation, right? So, Chris, you would have probably learned this in your prior journey. If not, we'll come back to this one, because anyways, this is part of the SAT syllabus where I'm going to start the whole syllabus afresh from 1st of February. So, whatever you have covered versus what you have not, we'll go through that, okay? But for the sake of proceeding with this one, this is my numerator, which I have just split into this form, divided by x minus 5. So this becomes, this is, if I take these two together and these two together, I can take x common here, it becomes x minus 5, and then here I will take minus 1 common and becomes x minus 5. Okay, divided by x minus 5. Now this becomes, see, I have this thing common between these two, so this becomes my factor like x minus 5 by x minus 5. So I can easily knock these two off and I got x minus 1. Correct? So this is the simplified value of the expression, the lowest term. Are you guys with me so far? Everybody? Now, this gives us the clue. If you look at this carefully, what would go wrong when you put x equal x minus 5? See, as soon as your denominator becomes 0, that is when the problem starts. This starts moving towards an unrealistic state of a solution. As soon as you try dividing something by 0, the obvious answer is infinity. Correct? Regardless of what you have in the numerator. If you have, except 0 by 0. Okay, so let's say if your denominator becomes 0, here you have a plus value, it becomes positive infinity. If you have negative value, it becomes negative infinity. So what you are trying to avoid to stick within the acceptable zone is make sure that none of your denominator doesn't have any value which is 0. Meaning, if you exclude this scenario from this whole expression, okay? Assume you have not resolved it, you are still here. If you exclude this scenario, any other value would work fine. So, because this is the only guy who can potentially get your answer to an unacceptable state where it will be something divided by 0. As long as you are able to avoid this scenario, this x minus 5 equal to 0, you will be fine. As long as you avoid this one, every possible value of x will be in the domain of the expression. So, I will let you guys digest and process this information. But what I'm trying to say here is, as soon as you factorize your expression, look at the denominator, what are the factors you have, and only thing you have to avoid is making sure none of the factors in the denominator is translating into becoming a 0. As soon as it becomes 0, I mean, again, these two you will anyways knock off and this will become your simplified form of the expression. But we have just simplified it. This is your parent expression. So any and every value of s that you are trying to find out, the time you put s equal to 5, this whole thing goes for toss. And you cannot see, this is the simplified form, but this is still a part of the expression. So you have to take that into account. So as long as when you simplify this expression and you put a disclaimer saying that when x is not equal to 5, then this tells the whole story, saying that this is an expression which can have every possible value of x except x equal to 5. Otherwise, this whole expression's value becomes unreal. Now, let me stop here and do a quick pulse check. Is everybody with me?
Yeah.
Yeah? Makes sense? Dhanushri? Dave?
Yes, sir.
Okay. So, this is the way you have to always look at it. Even if your ultimate goal is to simplify the expression, in rational expression into a lower term state, but then you have to make sure that you call it out. This is more like a disclaimer, right? When you buy medicine, it says, yeah, this is for headache, but it can cause nausea, right? So this is your disclaimer, where when you look at the expression as a whole, you are cognizant of the fact that this value of x is not going to be acceptable when you are looking at this expression. Are you with me? Yeah. Now, let's go to the next part of it. So, again, my request to you all would be, whatever we do in the class, whatever I tell you guys to believe, that is only like a jump start. How you will do in your actual studies would be a function of how much you are able to practice based on what we learn in the class. So always make sure that after the class, find out a quick time window, go to Khan Academy, pick up that unit, because I keep calling out the unit number, right? So it's unit number 4 and we have just started. Go to that unit, pick up that particular lesson and try doing the unit test without reading or without watching the video of what is taught. If you are able to do that unit test with whatever concept we have built, then I did a decent job as a teacher, you have done a decent job as a student. If you are struggling, if you are facing problem in solving those things in the unit test, that should raise the red flag for you guys and me both, that yeah, we did not probably understand it completely, or maybe I did not do a good job, right? So make sure that you always reaffirm your understanding by doing those unit tests. That's the only way I would stay relevant to you guys and you would stay relevant to pre-calculus. Yeah? Alright, so now let's look at one more scenario. If I'm talking about, let's say, x squared minus 7x plus 6 divided by x squared minus 1. So, how do we go about solving this? Ultimately, we are trying to get to a simplified form, and at the same time, we also wanting to make sure that we are aware of what are those non-acceptable values of x, meaning what is not in the domain of this expression. So, does anybody want to give it a shot to see how you factorize your numerator? No? You guys want an old man to solve this one as well? Okay, so that's fine. I mean, this is more like a so yes, Prisha.
Could you do x plus 6 and x minus 1? Or no, sorry, yeah.
X square minus.
Wait, for factoring, right?
Yeah, you have to factorize it. So you're saying that it will be x plus 6.
Oh no, x minus 1 and x minus 6.
So see, this is one big difference between you guys and me. You guys are much more intelligent than me. I am not. I'll show you here. If I'm doing this, you probably jump 2 steps, and I believe you're right. But if I were you, I'll say, okay, fine. I will break this into x square minus 6x minus x plus 6, and then try filling it out. Yes? This is what you would have done in your mind. I'm sure you did 2 steps together, correct? Yeah?
Yeah.
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 So you will pick these two together, and again, for all of you who don't remember this one, this is here, I mean, if you relate this with ax square plus bx plus c, the standard form of a quadratic equation, your a is your coefficient of x square and b is your coefficient of x and c is your constant here. You always multiply a and c, that gives you 1 times 6, which will be 6, and then you look at what are the possible factors of 6. You look at what are the possible factors of 6. You got a into c gives you a 6, and then you look at what are the factors. So 6 into 1 is the only factor, second factor could be 2 into 3, that's all. Between these two combinations, you are trying to figure out which two I will take which can add up to be the b. So 6 and 1, 7, that is what we did. So minus 6x or minus x. If you put together, if you multiply minus 6 and minus 1, this gives you a into c. So that is how we have done the breakdown. So that's essentially what Prisha would have done, and I mean that's the way to do it, right? So now here, from this one you got x common, x minus 6, and here you take minus 1 common, x minus 6. Divide by a square minus b square, it is a plus b and a minus b. So x plus 1 into x minus 1. And then this gives you x minus 6 into x minus 1 by x plus 1 into x minus 1. Yeah? So far I'm with you, right, Prisha? This is how you did? Okay. So, interesting fact. Unwanted fact also though. My own daughter's name is Trisha, so that's why sometimes if I say Trisha, don't start worrying about it. Alright. Here x minus 1 and x minus 1 you will knock off, and then it becomes x minus 6 by x plus 1. This is a simplified form. But then when you are trying to find out the domain, you are very clear that you don't want your denominator to become 0. And what are the possible scenarios when your denominator can become 0? When this is 0 or this is 0. So that means when x equal to 1 or x equal to minus 1, these are the two potential scenarios when your denominator could become 0 and this becomes an unrealistic solution or an infinity, whatever you call it. So that is why when you are trying to solve this, you convert this to this form and you say by simplified form like this, x minus 6 by x plus 1, with a caveat that x is not equal to minus 1 and x is not equal to 1. This tells the complete story of this rational expression and how do you define the boundary of it. Are you guys with me? Yeah? So, what do we learn next? Let's look at something called end behavior of a rational expression or rational function. Let's say I have a function which is coming as an outcome from an expression, right? I mean, so far I mean, there's a there's a fundamental difference between function and expression, right? When you say function or equation, you're essentially leaning towards an outcome, a value that you're interested in. When you say expression, it's like, I coming to the class and smiling all through for 1 hour doing nothing, right? So expression doesn't have an outcome. So that's why the next step is, okay, now we have understood what is expression. How do we relate that with how do we convert that to a function or spin off an equation out of it and then deal with it so that we have an outcome also to take into consideration. So let's say the expression that we were looking at, let's say x to the power 4 minus 2x squared divided by x minus 3. So this is a rational expression and we have converted that to a function. So this we will call it rational function. You are with me, everybody? Yeah? Okay. Now, what is the end behavior? Meaning, what all could potentially happen with a function like this? What are the extremes? When you talk about end behavior, you are essentially talking about the extremes. What would happen if value of x becomes way too big? Or what could happen when the value of x becomes way too small? So essentially we are saying when x is negative infinity or when x is positive infinity, what could happen? What would be the interpretation from this function? How do we say that, okay, for the value of x equal to infinity, this will be the value of this function. So when you talk about the extremes, the unrealistic values of x, what would be in layman's term, right? I always say, okay, when you're looking at a function, you can always assume that y is fx and equal to this, meaning whatever is the outcome from this, that you can call as a function of x or that you can relate with y. So basically when you are plotting this function in a coordinate plane, whatever is the overall value of fx that you are getting for every value of x, that is what you will be plotting against the y-axis. So that's why eventually you can always visualize that a function will end up being your y, basically, right? Again, there is no science to it. This is how I relate to it like a student, and this is how you will eventually end up seeing this, correct? So now I have a function. What we are trying to find out is what is the extreme of it. What would happen when the value of x changes to a very high value or a very low value? Very low as in infinity, negative infinity or positive infinity. And how would you relate that behavior? How would you kind of interpret that behavior would be? You are certainly looking at very high value. Okay? So, first thing you have to do is, you have to look at what is the maximum power or the exponent of the variable in the denominator. So here, you are looking at x to the power 1. So that is the maximum exponent of your variable in the denominator. Even if you have x to the power 4 above, don't worry about it. You will look at the maximum power of or maximum value of the power of the denominator, which is x. So what you will do is divide everything by x. So let me not jump the gun, right? I was telling that I do things step by step, so I should not be contradicting myself. So I will divide everything by x here, and then whatever I have here, I will divide everything by x again. Okay? And trust me, I have not given you guys any clue so far. I'm just doing something cryptic and I'm trying to convince you guys. Bear with me for 5 more minutes. Probably you will be able to make more sense out of it. Okay? So I have a rational function. I just looked at what is there in the denominator and what is the maximum power to the variable, which is 1. So I'm dividing the numerator and denominator by that power of x. Now look at what it becomes. So here you are dividing this by x and you are dividing this by x. So this becomes x to the power 4 by x minus 2x square by x. This is my numerator, and my denominator is x by x minus 3 by x. Yeah. So far, nothing cryptic. Yeah. So after doing all this, let me create some real estate on this board now. So here this becomes x to the power 3 minus 2x divided by x becomes 1 minus 3 by x. Now you look at this. When the value of x is, let's say, infinity, okay, positive infinity, or a very high value, this part will become 0. Agree? And this part will become, here also I am talking about x being a very high, exorbitantly high value and infinity. So my numerator has only, x in both the places. So this is, my numerator itself is infinity. Now infinity cube minus 2 times infinity divided by, this is 1 and this is 0. Something by infinity is 0. So this part is 0. So I am essentially talking about infinity cube minus 2 infinity. So long story short, I am just talking about my numerator being infinity. Right? There is nothing called 2 infinity and 5 infinity and infinity cube and infinity power 8. Infinity is infinity. Yet nobody has seen what exactly it is. Right? So this, my numerator is infinity. Now think of, so now if you relate that when the value of x is a positive infinity, my value of y also becomes, or the value of the function becomes infinity. This is one end behavior. Meaning, when you change, see, if I would have kept it like this, like x squared minus 2x squared by x minus 3, that would have put us in a situation where infinity minus 3 and that is trying to divide infinity power 4 minus 2x squared. That would have not given any conclusive view. But here, by dividing this by the maximum power of x, we are able to convert that to a form where my denominator, which is one of the biggest culprit, right? If your denominator, if you are trying to divide something by 0, imagine a situation where you are talking about dividing infinity by 0. We are already confused by seeing infinity. Now, if somebody is trying to divide infinity by 0, that makes our life even more complicated. Or if somebody tries to divide infinity by infinity, this is not 1, right? This is not 1. So basically, when you are looking at a rational expression, your first thing is my denominator should be neat and clean. Meaning, my denominator should not have a value which is confusing for me to proceed with the calculation. Am I making sense? Yeah? Okay. So basically, that is why the approach that I talked about, that okay, look at your expression, look at your function, look at the denominator, and find out the maximum power of x, the exponent of x, and then divide the numerator and denominator with the same value. So from that, what we are able to interpret for this particular function is, if my value of x becomes a very high number on the positive side, my value of this function, overall value of this function becomes infinity as well. If my value of x becomes very small number, let's say negative infinity, or something which is tending towards infinity on the negative side of the number line, what it will become? This will be negative, this will be minus 0, which is 0. This is fine. And this becomes negative cube minus 2 times, negative infinity cube, and then times infinity. So basically it's nothing but infinity. So basically it will be a negative infinity on the negative side. So from this one we can say that okay, fine, if my value of x changes to a very high positive value, my overall value of the function is again infinity. if it goes towards the negative side, correspondingly the value of the overall function is also tending towards the negative infinity. Relatable? Not relatable. Question to you guys. Are you guys able to relate to what I said? Now, let's look at one more example. Probably that will clear some more dust. Let's say I'm talking about a function where it is x to the power 4 minus x squared 3x squared by x squared minus 2. So applying the same approach, if I look at the denominator, the maximum power to the exponent, maximum power to the variable is 2. So I will divide the numerator and denominator all by x squared. So this will become x to the 4 minus 3x squared divided by x squared minus 2, and everything divided by x squared. So this becomes x power 4 divided by x squared becomes x squared minus 3 x squared by x squared becomes 3 divided by x squared becomes 1 minus 2 by x squared. Now you imagine a scenario. What happens when your value of x goes to a positive infinity or negative infinity? When this one goes to positive infinity, this whole thing is anyway 0. So this becomes infinity squared minus 3. You can literally ignore 3. This is infinity. When it goes to negative infinity, this is again 0. You don't have to worry about it. And again, negative infinity squared minus 3. You already have a negative infinity. No matter whether you are adding minus 3 or subtracting minus 3, doesn't make a difference. So from this one, you can relate that, okay, fine. When my function x moves towards a negative value, the value of x moves towards a negative infinity, it becomes negative infinity. When it moves towards positive infinity, the overall value of the function is also moving towards positive infinity. And you will see this difference in a different way whenever you are talking about. See, look at this. When we are talking about negative infinity, what will become? See, in this case, when we are talking about positive infinity, this value is infinity squared and minus 3, which is still on the positive side. When I am talking about negative infinity, the value of x is negative infinity. What happens? This becomes 0 and this becomes positive infinity. So here, when the x value is going to the infinity on the negative side, your y value or the overall function value is still, see, minus infinity squared. What will that be? Plus infinity only. So when your x is moving the negative direction, your overall function is moving the positive direction. So there is an interpretation that you can draw by looking at what is the end behavior. How is your x value influencing the overall value of the function? A moment of silence to check. Are you guys with me? So always when you're looking at a function or an expression, right? I mean, how do we solve the function? How do we deal with quadratic equations or a polynomial? Those things we are going to learn separately, and most of you would have learned as part of SAT, and for tests you would have learned it by yourself. If not, we are anyway going to cover it. So as part of this unit, we are not trying to get to the root of how do we sort out or how do we simplify a quadratic equation. But what we are trying to do as part of pre-calculus is, it is wanting us to start thinking about the expression. How do you relate your input and your output? How does the end behavior change based on what is the input that you are passing on to the expression? Yeah. So this here in pre-calculus side of things, you will see that whatever we have learned, we are trying to derive interpretation from that and then make some meaningful interpretation out of it. Yeah. I'm not saying that we're not going to learn a lot of things. We'll certainly be learning a lot of things, but you will see that pre-calculus will make us kind of explore it more even from a conceptual standpoint, where we start connecting the dots and say, okay, fine, I have a rational expression. How do I interpret that? What actually is the story behind? What is the correlation between the value of x and the overall outcome that we will get from the function, right? So those are some of the things that we will end up dealing with. So it will be a good idea to for you guys to make sure that you practice, you solve few sums and apply your thinking hat, because when you think, you will see that it's making a lot more sense. Yeah. Now let me give you guys some more food for thought. So Chris, do I speak very fast or it's okay?
It is good.
Okay. Now because Dhanushri, Prisha and Dev have already been tortured with my speed so far. This is your first time experience. I'm just checking if I'm just speaking for myself or I'm able to reach out to you guys as well. Yeah?
It's fine, it's fine.
Okay. Alright. Now, yeah, Dev, you were saying something.
I was just saying I understand.
You have no other choice because you've been dealing with me for some time now. So you would have either tuned your wavelength or you have been forced to follow me. Yeah. Sorry about that if I have been bothering you guys, but yeah. Let me know. I mean, on a serious note, whenever you hear me going way too fast, and if there's something that you're not able to follow, just don't bother. Just stop me, saying, "Sir, probably you're going a little too fast for me." Okay. Now, as I said, when you're looking at an expression, what is your objective? You're trying to find out some interpretable outcome from that. Now, let's look at a rational equation, a rational function like fx equals x to the power 2 minus, let's say, 9 by x plus 3. So when you see a rational function, obviously you are trying to simplify this, get to the lowest term, and then use that information for further dealing with it. Now look at this. It is a square minus b square, so it becomes a plus b into a minus b divided by x plus 3. And you are certainly tempted to knock these two guys off, and then you get x minus 3. So the first thing that you would want to do is obviously simplify, and this gives you, but what will happen? See, x square minus 9, so essentially we are talking about something that will plot a parabola, right? It's a quadratic equation, right? The numerator I'm saying. But we are talking about this overall function and trying to see what will happen in this case. So I'll probably give you guys a little bit of clue and then probably we'll disperse for today, so that whatever we have learned, just let's wrap our head around that one, and then we go to other things that I mentioned. I mean, if I would have covered everything that I mentioned, probably we could have finished the whole unit in 2 days. But we are not just wanting to rush, we are wanting to make sure that we understand the text. So now here, if you look at this one, there are 2-3 scenarios. Okay, one is when the value of x changes in a way that the overall value of the function or the value of y becomes infinity. Let's say if you put x equal to minus 3, this will become 0. What will be the value of y? Something by 0 becomes infinity. So if you are talking about, let's say it plots some graph. Okay? As soon as you hit x equal to minus 3, no matter which direction was the graph was going, it shoots up this way. Let's say the graph was so far going this, and as soon as you hit x equal to 3, it went to infinity of y. I mean, now for this x value of x equal to 0, x equal to minus 3, this is not x equal to minus 3 anyways, but just if you assume that this is minus 3, the value of y immediately shot towards infinity. This is called vertical asymptote, meaning when the value of x changes to get you infinity for the overall function, that is called the vertical asymptote. Similarly, the value of y for an infinity of x is called the horizontal asymptote. And again, these might sound like cryptic terms, but don't even worry about it. Horizontal asymptote is when x value is going to infinity, and vertical asymptote is when value of y is going to infinity, or the function value of the overall function is going to infinity. And that you'll be able to find out or interpret just by looking at this. What are the possible values of x that will lead to the vertical asymptote versus the horizontal asymptote? Yes, Prisha.
Sir, could you write limit notation for this?
Say that again.
Can you write limit notation for this?
For the asymptotes?
Yeah.
So we'll certainly do that in the next class, so don't worry about it. Right now I'm just seeding that thing, okay? So what do we interpret from from the function to understand what do we mean by the horizontal or vertical asymptote? Okay, so I'm just seeding that and leaving you guys here, so that in the next class when we talk about the zero of a function, it's called discontinuity removal point. Let me tell you exactly what is that called. I had mentioned that point. I keep forgetting the terms. Removable discontinuities are zero or the asymptotes. So we'll talk about all that, and we'll do that in relation to the function, rational functions. Okay. So far we have just understood what is rational function, what do we mean by the end behavior of it, and how do we look at the different input and output scenarios, which helps us understand those extreme cases when the value of x or y starts marching towards the infinity value. Yeah? Does that make sense to everybody? Yeah? Alright, so now my only request to you guys would be, when you go to unit 4 on Khan Academy, high school and college math pre-calculus, and inside pre-calculus go to unit 4, first 2 lessons you can just try doing the unit test by yourself. Just do it for the sake of fun, okay? Don't do it with any stress or worry that you have to finish something. It's not a task. You're just doing it to see if you're able to apply these concepts to be able to solve those problems. If you're able to do it comfortably, then we have learned something. If you are getting stuck, you know whom to bother. Yep. Alright. With that being said, I'll let you guys go. Enjoy the rest of your evening, and we'll meet again next Wednesday. I mean, obviously we are meeting on Saturday, Sunday any which way, but yeah, for pre-calculus. Yep. Alright.
Alright, thank you,
Alright,
sir.
bye bye, take care.
Thank you.
Goodbye, bye bye, good night.
Thank you, sir.
Bye bye.